right, now that the first data analysis, I was expecting an assignment from you. Did you see the announcement that you have an assignment? Because none of you responded to my announcement. The assignments, yes, on Blackboard, yeah, yes. Yes, we had an assignment that was not graded. Let me show you, and if you guys are having difficulties, so you go to announcements, and you see that you had an, okay, no, there's no, okay, so it's my bad. I did not send any, but how come? How come did I send it to another? All right, no problem. So let me tell you what you had and maybe give you a week to do it. And let me check how come I did not. So it was something simple. I wanted you to solve this on your own. Okay. How many sig figs is that? I wanted you to solve the temperature of the guy on your own. This one, find the average and the error on the average. And this one. Okay. So this one I already did with another class. So the question is, do you know how to find the error on the average, and do you know how to find the average? If you watch the slides again, you should be able to learn how to find, in this case, the number of significant figures. This is one. Another thing, you should know how to find the average and the error on the average. And in this case, how to find the average again and the error on the average. So you didn't have actually an assignment. Maybe I said it orally, but I never wrote it in an announcement, and this is bad from my side. So I will write it again. I will give you a new deadline, and you will only have to answer those questions. This is not graded. I just want to make sure you know how to do this. And last time I saw you, we reached slide number 17. Slide number 70 is a very easy example. Slide 18 is difficult, so I'm gonna change this into an easier example, because with sine function and alpha, I had big issues with another class. So maybe I can create a new assignment for you. Okay, are you with me? All right, so now you have, so if I give you a quick reminder of the content, we discussed significant figures, how to count them and how to round, measurements, how to do a measurement and how to find the error on the measurement, discussing the uncertainty of the measuring tool and how to do the rounding. Then we discussed why we do averages, why do we take many trials, and how do we do the averages and the error on the average. You also had a video in here explaining that you can find the error on the average following this equation or using simply your calculator. Please try to watch this video many times. And now the question is, F equals to ma. This is Newton's second law. Do you know it? All right. Your friend measured the acceleration using a special measuring tool, and your friend knows the uncertainty on it. So the acceleration is 2.2 meters per second squared plus or minus 0.1. So you can see it's not super precise because you have a big error compared to this value. But I don't really care about why it's not precise. This is given to you. Also, your friend did the measurement for the mass, and your friend actually found the value of the mass to be 15.8 kilogram plus or minus 0.4 kilograms. Now your job is to find F. How would you do it? How do you find the force? Anyone? Speak up if you know the answer. You mean the value? Because I do like this value, you mean? Okay. So M times A, you do 2.2 times 15.8, or am I wrong? Okay, do you have a calculator in front of you? Yeah, you guys always have a calculator with you. It helps because you're gonna learn how to use many functions on it. And by calculator, I mean a scientific calculator and not your phones. If possible, you need to have one, okay? So what is it? 38, 37.4. Can you give me more decimals? 34.76. Awesome. Can you think of a unit? Yes. Yes, you can say meter times kilograms per second squared, or you can simply say newtons, because the unit of a force is newtons. All right, now we need to learn how to find the error on F, because I have the error on A, I have the error on M. How can I simply find the error on F? Do you have an idea? F is not an average, so I cannot use the RMS. F is not a directly measured value, so I cannot find the uncertainty on the measuring tool. How would I find F? I need to deduce it from this guy. Let me underline it, and this guy. So I know the error on A, I know the error on M. I need to deduce the error on F from 0.1 and 0.4. How do you do it? It's an idea, although it's wrong. The only way to do that is to do this equation. This is called propagation of error. All right? Sounds awful. Let me try to break it down for you. Maybe on a whiteboard. Let me create a board for us, and I'm gonna use it to draw. Okay? And let me minimize this one. I don't need it. Okay, so draw. Whenever I record my session, the apps I have will become a little bit slow, which is okay. So I have F to be equal to MA, right? You can see that M is a measurement and A is another measurement. So to be able to find the error on F, I'm gonna call it error alpha F. I'm gonna create a very big radical sign. And I'm gonna see that I have two measurements, right? So I'm gonna open two parentheses, all this squared plus all this squared, exactly like the Pythagorean theorem. Do you know the Pythagorean theorem? That states that C squared is equal to A squared plus B squared. This is not similar to the Pythagorean. It's basically the same idea. All right, so I'm gonna do the derivative of F with respect to M. Do you know what derivatives are? Okay, we can have a quick review. And then derivative of F with respect to A. These are called partial derivatives because I'm doing a derivative, taking M to be my variable, and then repeat taking A to be my variable. And then multiply by the error on M, and now multiply by the error on A. Okay, so how do we do the derivatives? I'm gonna give you a quick reminder. If I have a constant times x, you tell me what's the derivative. It is the constant itself. If I have constant times x to the power n, what will be the derivative? Who's speaking up? شو شاطر انت يا كارل. Excellent work. Okay, you guys are enjoying the physics course? Okay. Okay, if I can answer any of your physics questions, let me know. All right, the final question I'm gonna ask you, C over X. Do you remember what's the derivative of C over X? Maybe this you can't remember. It's negative C over X squared. Okay, fine. All right, now I'm gonna use another color to be able, so this is my function. When I say derivative of F with respect to M, it means that M is my X, my variable, and this is my constant. What will be the derivative of F if M is my variable? What would you say? A. Okay, it's like I'm saying it's X times A. And what would be the derivative of F if A is my variable? It's M. All right, now back to my slide. This would be M, this would be A. I have M, I have A, I have alpha A, I have alpha M. I just plug in the values and get an answer. By the way, you would see that here I wrote df over dm, but here I wrote delta f over delta m. This is partial derivative, meaning I have many variables. Now I need anyone. It could be Leia. Leia is still with us? Yes, Leia, can you try to do the calculation? Like create a very big radical and do m times alpha a squared plus a times alpha m. Carl, I want you to do the same calculation as well. And please throw at me your answers so we can compare them and try to write them down. And maybe now create another example for you. 1.8 is your answer, Newton. I want to see if Leia agrees. Anyone can try, by the way. Carl, you can repeat your calculations to confirm. Leia, any answer? Did you do the square root, the big radical? Did you do the squared? Double check. So it's m times the error on a. Some students would mix. They would say error on m. Yeah, I think my answer is 1.8 as well. Anyway, Leia, check it out. I need to got it? Okay. So back to slide number 13. Uncertainties must be one sig fig, must have a unit. The measurement must have the same number of decimals as the uncertainty on it. And now let's try to fix it. No, if you round to one sig fig, it's gonna be 2 because 1.8 is very close to 2, right? Okay, so I just rounded my answer to one significant figure. Now I'm gonna write that F is equal to 34.76 newtons plus or minus 2 newtons. Okay, yes. And I'm gonna check, do they have the same number of decimals, these two? How many decimals do you have in the error? No decimals. So this should have no decimals. Can you round it, please? No. I mean, this one has to be fixed. This one, you should not touch it. It's perfect. Please fix this one to have 0 decimals. 35. Thank you so much. And now this is a perfect answer. So again, for you to be able to find the perfect answer, you have to follow this. Make sure your uncertainty is one significant figure. Make sure you add a unit and make sure you fix the number of decimals. Okay, so that was a nice example we did. Now I want you to try something on your own. I don't want sine alpha. This is really out of the level of the course Physics 111. Let me give you something easy. Ohm's law. Do you know Ohm's law? Exactly. U is equal to R times I. Okay, the question is, U is given 3.2 volts plus or minus 0.1 volts. I'm gonna give you I to be 20.02 milliamperes. Okay, maybe I want to write volts in here. Okay, plus or minus 0.04 milliamperes. And the question is, you need to find R and the error on R. Okay, so this example is a little bit more difficult than this one because you need to find R and not U, and you have some unit conversion issue you have to consider, but I really want you to do tons of mistakes to be able to learn from your mistakes, okay? So far your assignment will cover slide, where is it? Slide number 3, everything not answered. And the slide number 14, slide number 16, and slide number 18, okay? But I'm gonna write it in the announcement. All right, I'm done with this PowerPoint presentation. I was meaning to finish that the last session, so we are like a little bit late, which is okay. Yes, please ask. Yeah, yeah. Okay, so this equation, we usually use it when I'm not being able to measure, like F, I cannot measure it, and it's not an average. It's a calculated value. The only way to find F is to calculate this. So the error on the calculated value, you use this big equation, and this big equation has a name. It's called propagation of error. Okay? So you either directly measure or find the average or do a calculation. If you directly measure, you take the smallest subdivision divided by 2 for an analog measuring tool. For a digital measuring tool, you just take the smallest subdivision. For an average, you do the RMS error. And for the calculated value, you just do the propagation error, meaning this very big radical. Okay? All right. Now, this is session 2 of 2. It's only graph skills. All right. And I think if I go into the content, I don't want to do item 5. Not today. So let's go over item 1, 2, 3, and 4 and chill a little bit. And you will be asked some questions that I'm going to call assignments. Okay. Graph skills. A graph is a communication tool. How is it a communication tool? Why do we need linear relationships? 3, how do we calculate the slope? And 4, why? What is the slope needed for? Okay, so a graph is a communication tool. You did graphs back when you were in high school, right? Yes? Yes. Who was reading your graphs? So you did it for someone, I suppose. Yes? Who was reading your graph? Why were you doing those graphs? To visualize a certain behavior, to visualize how your data actually behave. So who was reading the graph? Basically your instructor, your teacher, right? All right, in the future, you may end up in the medical school or in the business school. I don't know, you would be writing reports, and who would be reading your reports? Maybe the patients, maybe your customers, maybe your, I don't know, some peers in your team. So a communication tool means it has to be clear enough for it to be a good communication tool. I'm gonna show you some graphs. This is a very pretty graph. You can see a title. You can see that this axis is labeled, and this one as well. This is pounds of tobacco per capita, and these are the years. You can see some colors and a legend. Each color represents something. Fair enough. If I move to this graph, I have no idea what the title is and what it represents. If I look at the x-axis, I don't see any units. Maybe they're talking days or months. I don't know, or maybe hours. I can see the y-axis brand A, B, C, and D, and E means something. The legend is visible though. If I look at this graph, the title means nothing. The legend means nothing. It shows me that this is blue and this is, you know. If you look at the x-axis, y-axis, I don't see any label, any unit. This one looks so cool. The y-axis is recent activity. I don't know what type of activity it is. It could be radioactive activity. Maybe the unit is becquerel. I don't know. The x-axis, I can see June, May, July. The legend is not clear at all. 3, 1.5, what's that? Index, money, dollars, I don't know. So every time you need to draw a graph, in your case, you either get a graph paper. How do you do it? How did you do it back in high school? A graph. Did you ever plot a graph? Yes? Yeah, if you are given a graph, how do you plot it? How do you create a graph? How did you do it back in high school? Exactly, on a graph paper. So now in the lab, you can get a graph paper and do the graph you want, and then use your phone to take a picture and then insert the picture in the lab report, okay? Cool. Or you can use Excel. I'm gonna show you how to use Excel. I'm gonna open a file, all right, a new file. And I will show you how I will put X and Y, okay? So this is X and this is Y. Maybe make this a little bit bigger, okay, for you to be able to see it. And I want you to watch the recording of our session again so you can try it on your own laptops. So I'm gonna put some values, 2.4, 3.1, I'm sorry, 3.1, and this is 4.8. I'm gonna take this one to be 2.2, this one is 5.1, this one, those are random values by the way, and this is 8.2. All right, now I need to select the values without the X and Y, but please make sure you put X first, then Y, and not the opposite, and go into insert. I will use the scatter that has no line and nothing. I want to do the line in a manual way. So this is a nice plot, okay? You can add a chart title. You can go to chart design and add chart elements like you can label the horizontal, the vertical axis, add a unit, create a legend, and make it look nice. All right, so this is how you will be plotting. Isn't this much faster, Nazih, than a simple graph paper? Yeah, it's fast. You have everything you need, and you can, I think you can do copy and paste in your document, the Word document, your lab report. Okay, or take a screenshot and add it to your topic. Anyway, I'm done with item 1. A graph is a communication tool. 2, linear relationships. I want to show you this. Do you think this is linear? Yeah. These are measurements, and the measurements are spread, and you can see you have some errors. They're not all on the line, but these are experimental errors, and maybe I can average this line to a straight line. This too. So this is a linear relationship with a lot of experimental errors. Do you see it? Yeah, and say it again, Nazir. Yes, it is linear, but with a lot of experimental errors. This is also linear, but you see the slope is negative, and you see a lot of experimental errors. This doesn't look linear. It looks like a curve with a lot of experimental errors. Do you see it? All right. Okay. Now I want you to look at this one. This is T versus L. T is the period of the pendulum, and length is L is the length of the pendulum. Do you think this is a linear relationship? It looks like a curve, yes. But if you plot T squared versus L, you will see it becomes linear, because T is not proportional to L, but T squared is proportional to L. So you can make your functions to become linear. I want you to look at the equation of the straight line. What is the equation of a straight line? Who knows? Exactly. Yeah. So you can say mx plus b or ax plus b. Your Casio calculator would say bx plus a. So it's any constant x plus any other constant. Can you tell from this equation, taken that t square is y and L is x, which one is the slope? Awesome, this is the slope. And what is the y-intercept? Carl, I'm so proud because you said it's negative, because a lot of students would not see the negative sign. Another question, what is the unit for the y-intercept? Because in math, they don't have units. In science, everything has a unit. the unit of the y-intercept is exactly the unit of y, which is in this case second squared. Yeah, it's the period squared, and you can see the unit after the slash, it's second squared. What do you think the unit of the slope is? The unit of the slope. Who's that? Carl. You're impressive, Carl. You're impressive. Mama, you guys, are you getting it? Did you get the answer? Carl, explain. Okay, so what Carl is trying to say, he said that the slope by definition is the gradient, which means the rise over run, or a change in y over change in x. So the unit of the slope should be the unit of y divided by the unit of x. So second squared divided by centimeter squared. Okay, I will remind you about those in a moment. What else? This one, you see it's super linear, and you see the equation of the straight line. You also see that this is labeled with units, total mass in grams, number of crackers, and it has a title. And very well, you don't need a legend because it's only one variable. All right, I want you to look a little bit about this R squared coefficient. Have you ever saw it before? The R squared coefficient. Maybe not. I'm gonna stop recording